Let's get started with part 1 of Lab 8. And here we're going to be talking about wave refraction, and we're going to be working with this map here that shows a headland and a bay. This will be the land here, shown in this grayish pattern. And then in this whitish pattern would be where the ocean is. And these lines here are contours of the base of the ocean. So this is essentially saying how deep the ocean would be at any particular point here. And you can see it kind of mimics the land there as it wraps around the headland and goes into the bay there. So the first question you have is if wave crests are spaced 160 feet apart, what depth would those waves start to feel the bottom? And all you have to know there is the wavelength, because crests are 160 feet apart, that would be the wavelength. And you have to know the relationship between the wavelength and when waves start to feel the bottom, which is half the wavelength. So you'll fill in that answer there, but here's what I want to show you how to do. What you're going to be doing is you're going to be tracing on these waves and seeing how they're refracted by as they move towards the shoreline. So the instructions are listed here, but let's just take a look at this. Here we have the contours once again on the bottom of the ocean, 20-foot contours. And then we get out to this 100-foot contour, and this 100-foot contour has a bunch of dots on it. So you're going to use this handy dandy little arrow here. And let me just make some copies of it just so I don't have to keep reusing it. And you're going to take it and you're going to put it along the contour line until the tail of it runs just perpendicular to the contour line, and it's spaced right over the contour. And then you go into your drawing tools, you'll draw, and then you'll draw on a line from this contour to the next contour. You can put a little point on there or just use the arrowhead. And then you go back and do it again. And I'm just going to go into my, just going to go ahead and do it for all of these, and then I'll draw on the arrow itself. Looks like maybe something like that, a little more twisty. Okay, and there's my next one. There's my next one. Its point would be about there. I'm going to put on my next one. Starting there. Point would be about there. Next one. Have to estimate this a little. You'll be able to draw this on. You can do these one at a time, or you can put all of them on for one. Put somewhere around there. And then the last one here. And you can see that after we put in all these arrows, it's not going as a straight arrow from that first line, but it's kind of getting bent around here. And then you're going to put on a blue X. Wherever that arrow hits the shoreline. So after all those arrows come in, they hit the shoreline right here, and you're going to do that for each one of these. And just to go back to the drawing tools for a minute, we would connect this up to here, to here, here to here, here to here, and here to here, and then that would be the entire length of that arrow there. You're going to do that for all of these points here, and you're going to see the pattern that results as far as where the wave energy is concentrated and where it would be more spread out. And then once you have that information, you have all your X's on, you can say where the X's are furthest apart, the shortest distance, the longest distance, and how that relates to the energy that's arriving from the waves.